Okay, let's take a look at this problem. And this is following an example in the book, maximizing profit for a company. And here they give us a formula. Our profit, P of XY, is equal to P of X times X plus Q of Y times Y minus our cost function. So we've got P of XY. It's big P for profit. This is little p for price. Is equal to little p times X. So we're going to take 16 minus 1 half X times X plus our Q times Y. So Q times Y. So that'd be 37 minus Y times Y minus, and you have to make sure you put parentheses here, the cost function. Because oftentimes you have multiple terms here, so you need to flip the sign of everything. So we got 10x plus 19y minus xy plus 19. So going to give us 16x minus 1 half x squared plus 37y minus y squared. And the negative, flip the sign of everything inside. So it becomes a negative 10x minus 19y plus xy minus 19. Got 16x here minus 10x. That gives us 6x. Minus 1 half x squared. 37y minus 19y. Go back to bed. 18y. Can't do basic subtraction. And then I got minus y squared. And then plus xy minus 19. Okay. Now go down here. Let's look at our steps. That's where we're at right here. We just got our main function. Now we're going to find a partial derivative with respect to x. Partial of p with respect to x. You take the derivative just like normal, treating everything except for x as a constant. So derivative of 6x is 6. Derivative of negative 1 half x squared, take your power, put it out in front. Negative 1 half times 2 is negative 1x, or negative x. This does not have an x, so this is a constant, so that goes to 0. This does not have an x, so that's constant, goes to 0. xy, since x is what we're working with, y is a constant, so the derivative of x is 1, so we've got 1y or y. And minus 19 goes to 0. Partial with respect to y. 6x, 0. Negative 1 half x squared is 0, because there's no y's there. Derivative of 18y is 18. Minus 2y. Plus, and again, the x I treat as a number, like same as if I had 3 there. If derivative of 3y would be 3, the derivative of xy would be x. And negative 19 drops away. So those are partials. Then, what we want to do is, they say set each one equal to 0. But basically we want to solve the system of equations after we set them equal to 0. So we got 6 minus x plus y equals 0. And 18 minus 2y plus x equals 0. Now I'm going to get all the variables on one side and numbers on the other side. So here I'll take the 6 over. So we've got negative x plus y is equal to negative 6. Here I'll take the 18 over. Now rearrange it. So x is first, minus 2y, and I took the 18 over, so it becomes a negative 18. And double check all my signs. Well, now we can add these together. Negative x plus x cancels. Y minus 2y is negative y equals negative 24, which gives us y is equal to 24. Now we want to plug that back in and solve for the other variable, solve for x. So I'll plug it in here. Doesn't matter which one, but this one looks easiest. So I got negative x plus y is equal to negative 6. We just said y was 24. Take 24 becomes a negative 30, and we got x is equal to positive 30. So our point is 30, 24. That's our critical point. That's what we just found here. Now this is referring to our from the d-test. So we're going to go over to that, and then we'll come back to this example. Let's try to find it here. Here it is. Now, in order to use this, you have to find these partials right here. Okay, so this is our critical point. Keep that in mind. That's what we're working with. So if I continue with our partial with respect to x, take derivative again with respect to x. 6 drops away, y drops away, derivative of negative x is negative 1. We also need the partial of y taking the derivative again. So the second partial. So we're taking our partial with respect to y, and we're taking derivative again with respect to y, which gives us negative 2. 18 and x would be constants, would drop away. And xy. So taking partial of x, partial with respect to x, and we're taking derivative of it again with respect to y this time. 6 drops away, negative x drops away, they're both constants. Derivative of partial with respect to y, this would be 1. Okay. Now this tells us we need to multiply these. So I'm going to have negative 1 times negative 2, and was it subtraction? Yeah. Minus, and then we're going to square this. That gives us 3. That's bad. 2. Minus 1, which gives us 1. Okay. Now D is greater than 0. So it's one of these. It's not a saddle point because that's less than 0. Fxx is less than 0 or greater than 0. Well, it's negative 1. So negative 1 is less than 0, so it's a relative max. Now let's see what all they're asking for, though. Now here they're asking for the product A quantity and product B quantity, 30 and 24. Well, that's what we found right here. They're also asking us for the price. Well, we go up to our price functions for each one. We got price for this is 16 minus 1/2 x. And the other one is 37 minus y. 16 minus 1/2 times 30. We get p is equal to 1, which is where they get this 1 from. Now for our other one, q is equal to 37 minus y, and we said y was 24. So we got 37 minus 24, which gives us 13, which is where this 13 comes from. And then to actually find a maximum profit, what you're going to do, and I won't actually finish this, but here's our product. You plug in this x and you plug in this y for the x and y's here, and then this value should give you your answer. And that's how you'd work that problem.